In this video, we'll talk about inverse functions. I have an example here, f of x equal to x cubed plus 2, which is sketched right here. And we will find the inverse function. The notation for an inverse function is f inverse x. F inverse x. An inverse function just involves all the x values being switched around with their corresponding y values. So here's 3 points on this curve. Negative 1, comma 1, 0, comma 2, 1, comma 3, as you can see in the picture. And if I'm talking about f inverse, you just simply switch each x with each corresponding y. So negative 1 will go here, and the 1 will go there. 0, 2, switch them around. Switch x with y. 1, comma 3, 3, comma 1. And we can plot these. We can actually sketch the inverse function without even having its equation yet. At 1, it's negative 1. At 2, it's 0. And at x equal to 3, y is 1. Yeah. This is f inverse. So I'll put that notation. Now, all inverse functions are symmetrical along the line y equals x. I'm going to get these points out of the way. The line y equal to x, that's just a line cutting right up through here, through the origin. I use dashed lines just to represent it. Yeah, it'd be right here, right here, right here, right here, right here, right here. I mean, I'm just going to go meow, 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 along this dotted line, all right, which is y equal to x. All inverse functions are symmetrical. All right, so I can actually make a sketch of this because it's going to reflect that blue curve. F inverse would just come through here, just kind of go, see how it's right there, touching around there? All right, and it reflects this sketch. Comes out here. Make this line solid, it might help you really to see it. I mean, this is y equal to x. But you can see the symmetry. You can see this symmetry. So it cuts through there. These would actually touch the same location right there. Alright. And now sketch f inverse. Right there. That red curve. I should point out that not all functions have inverse functions. Yeah. Just because you have a function, f of x, it doesn't mean it necessarily has an inverse function. Now this function has an inverse function. But let's look at f of x equal to x squared plus 2. Now that's a quadratic function, right? A parabola, which looks like that. We all know this x cubed plus 2, which is drawn right here. All right. Looks like that. And to determine if a function has an inverse function, you perform a test. It's called the horizontal line test. Yeah. Draw horizontal lines to the function. As long as you only hit once, it passes the test. Yes. This function has an inverse. But as you can see, you hit twice right there with the horizontal line test. This function, no. F of x squared plus 2, while it is a function, it does not have an inverse function. It failed the horizontal line test. And when a function has an inverse, it's called a one-to-one function. This is a one-to-one function. This is not a one-to-one function. And as you can see, just right there, we're going to draw it again here. Hits twice. But say it like x equal to 1, you get a 3. At x equal to negative 1, you get a 3. The y value 3 was taken on twice in this function. So it's not 1 to 1. Yeah, it's actually 2 to 1. So that's how you can determine if a function has an inverse, the horizontal line test. Well, let's now find the equation of this red curve. We see what an inverse function is all about, but can we find the equation represented by that curve we've drawn? Takes 2 steps. So this is defined in an inverse function. How do you find an inverse function? So, put the notation. F inverse x. 2 steps. Step 1. Go into this function right here and switch around the variables x and y. Remember, that's y and that's x. Okay. X equals y cubed plus 2. That's the first step to find an inverse function. Switch around x and y. Y and x, now x and y. Step 2. Now that we've switched x and y, you need to solve for your new y. You have to solve for that new y that just emerged right there. You have to isolate that y. So how do we solve for y? Let's start out by subtracting the 2 on both sides. You agree? If you subtract a 2 here, and if you subtract a 2 on this side, you get x minus 2 equal to y cubed. And then just take the cube root of both sides. The cube root of y cubed is y. And then we get the cubed root of x minus 2. There it is. Let me circle that. Ooh. There's f inverse. F inverse is the cubed root of x minus 2. That's that red curve. So that's how you find the equation of an inverse. 2 steps. Step 1, switch around x and y. Step 2, solve for your new y. Isolate that new y after you switch them around. Okay. Can we verify that these are inverses? We sure can. There's a theorem that states that f of f inverse must be equal to f inverse of f. That sounds so complicated, but it isn't. And we are now going to verify that this is actually the inverse. Let me put it down. This is what we found, the cube root of x minus 2. Let's verify that that's the inverse of this function. There's a theorem, as I pointed out, that says f of f inverse must be equal to f inverse of f. It's composite functions. And they will equal the variable x. This will equal x, and this will equal x. So f of f inverse must equal f inverse of f, which must equal x. Don't let it be too complicated. If you want to call it f and g, go ahead. Okay, let's call this f inverse g. Here, you're going to be g. And so we're going to show that f of g equals x, and g of f equals x. So let's start with f of g. Composite functions, which is f of g of x. We'll put all this, substitute into that x, so we'll get the cubed root of x minus 2. All cubed plus 2. Recall, this is how we do composite functions. I just simply substitute all this right here for that x. And cube root cube, this just becomes x minus 2 plus 2 minus 2 plus 2 is 0, and we get x. Check that off. To complete this verification, let's also show that g of f also equals x. So now we're going to do g of f, which is g of f of x. Alright? So that means, when we do g of f, we need to take this function here and substitute it right into that x variable. Alright? So if we do that, look, you got the cube root minus 2. There was an x here. We're going to substitute that x cubed plus 2. Right in there. 2 minus 2 is 0. we get the cube root of x cubed. Cube root of x cubed is x. There, verified. So that's inverse functions.